Stats with StatCat.
That's me. Hi there. In this video, I'm going to talk about how to go about reporting an independent t-test result. So what we want to do when writing up the result is to state the purpose of the test, the variables we have, and some descriptive stats. Then report the t-value, degrees of freedom value, and p-value. And something we really don't want to forget is to include the effect size. To help me go through this, I'm going to use some real example data from a study where with about emotional well-being in school kids, and we're going to focus on comparing the emotional well-being of male and female school students from that data set. If you're interested in that data, links are in the description below. So I'm going to be using the SPSS output that I've gotten from running an independent samples t-test, and just run through what the output gives and what you want to extract from that output in order to write up your result. So first of all, you will get some sort of descriptive stats usually from your t-test output, and like so here. And what I can extract from this table is that the emotional well-being of the male students here, the mean value is higher than that of the female students, as you can see here in the table. And I've just reported that here on the slide. Then we want to grab our t-test information, and this can be a little bit overwhelming when you first see the table that SPSS gives you, because it gives you a lot of stuff that you don't actually need when you're writing up the result. Pretty much on this slide, the second half of the table you can kind of ignore. What you want to get is the degrees of freedom value, the t-value, the p-value. We also want to get effect size value. Now, also in SPSS, it'll give you a table where it has equal variances assumed and equal variances not assumed, and it gives you two rows to help you decide what row to read off. If you click a little checkbox when you're running the test, you can usually get, depending on whatever software you're using, and you can definitely get this from SPSS, is you can get a Levine's test for equality of variances. And in the current example, that little test came out as non-significant. That is the sig value here, or which sig is just the p-value. The p-value here is greater than 0.05, which means that equal variances can be assumed. If the p-value here was less than 0.05, then that would mean that the equal variances could not be assumed. But it is non-significant, so we can assume that. So that means we can read off the top row in the current example where equal variances can be assumed. So therefore, we can get our little values. So to get the degrees of freedom, or DF value, in the current example, you just look, it's in the DF column here, 765, put that in the brackets. The T value is just here, where it says in the T column. In the current example, negative 9.47. The P value is under the significance area, and generally you'll be interested in a two-sided P value. Sometimes you might be interested in that one-sided p-value, but that's a video for another day. Vast majority of times, people are interested in the two-sided p-value, so you look for that. And in this example, it's less than 0.001. So that is less than 0.05, so that is a statistically significant result. In this table, it doesn't give us the effect size, so that's missing. We're almost there, but with the SPSS output, it also does give, if you check a box, you can also get a effect sizes output box, and it gives you several options. I'm not going to go through in detail the three specific options here. I'm just going to focus on using Cohen's d because that's the most commonly used value, and also note that they're all, in this example, they're all very, very similar anyway, right? So it doesn't really matter which one you use. A lot of the times they will be really similar, but yeah. Anyway, we're just going to use Cohen's d. And so for this example, we've got our t-test result from the prior info, and now we've also got our Cohen's d result, which you get as in SPSS, it's in this point estimate column. So here, Cohen's d is negative 0.68. To interpret Cohen's d, one very commonly applied set of guidelines. Now, there are different guidelines out there, and that's a deeper discussion for another day, but one of the most common sort of guidelines gets used are the pretty old school Collins 1988 guidelines, which are on the slide here. So in the current example of 0.68, that sort of sits, in between a medium to large effect. So to write up our result based on what I mentioned we want to talk about in at the start of this video, now that you've gone through your output and you've got all the info, you can write it up. And I've got an example of that on the slide here. So note that in the example, how I've written it up corresponds to these little 3 bullet points that I've got. At the start, we're stating the purpose of variable and descriptive, so that's what's stated here. You can have a read in the green font. I've reported the t-value, degrees of freedom, and p-value in the orange here, and I have also included the effect size in the purple at the end there, and also kind of added a little bit of interpretation of that Cohen's d value at the end of the write-up. And so there you go. That's how you can write up an independent t-test result. Thanks for listening.